All right, welcome to section 1.5, Solving Inequalities. Glad you could make it today. Let's get started. First thing is, let's take a look at our objectives for today. Actually pretty straightforward today. We've got two objectives. First of all, we want to be able to solve a one-step inequality. And secondly, we want to be able to solve a multi-step inequality. All right, so first of all, let's review some of the inequality signs. Instead of having an equal sign in our open sentence, we will have an inequality sign, which could be one of several things. First of all, we might have greater than. Okay, when we see this sign here, we write that, or we say greater than, because we read left to right. And so if I were going to write something here like x is greater than 5, the x is on the bigger side of that inequality sign. You might have heard when you were in elementary school, they talked about, the alligator eats the bigger thing. Okay, so the x is the bigger thing in this case. It's greater than the 5. The 5 is on the pointy side, so we would read that as greater than. Less than would be the opposite way, so we might say here y is less than -7. That means y is now the smaller thing because it's on the pointy side, but since we're reading from left to right, this time we would say y is less than -7. And then of course we could have a situation here where it's greater than or equal to. So what signifies that is when we add the equal sign down here underneath, and that means it's not only greater than, but it can also be equal to. And of course less than or equal to, same type of thing there. All right, solving inequalities. Basically what it boils down to is solving inequalities, we follow the same steps and the same procedures as solving equations. There's just a couple of little differences. First thing, we want to pay attention to the inequality sign. First of all, sometimes people kind of forget when they're working quickly, and instead of continuing to write less than or greater than on their work, they might slip in there and start writing equal. So make sure you're not just going to write equal without thinking about it. You're going to still want to write less than or equal to, or whatever your sign is there. But there is one situation that you got to really pay attention to that's going to be different than solving equations, and I'll go over that in a minute. And then of course the other thing is we're going to graph our solution set. So we'll take a look at some graphing here as well. All right, so I want to go through a few situations here with addition, subtraction, multiplication, division, where we know what the numbers are ahead of time. We know that 8 is greater than 6. Most of the time when we're working with an inequality, we have x is greater than 2 or y is less than 5, and we have variables in there. But I want you to see a situation where we know what is greater and what is less than, and how what we do affects it. Okay, so first of all, with the addition here, we know that 8 is greater than 6. Well, if I wanted to add 2 to 8, remember our rule that if we add 2 to one side, we need to add it to the other side? So I said, well, what would happen if I followed that rule? That's what we did in solving equations. 8 plus 2 is 10. And 6 plus 2 is 8. Is that still true? Is 10 greater than 8? Yeah, that's still true. Okay, we can say that's true. So here's the thing is, we know that when it comes to addition, when we added 2 to both sides, that worked exactly the same way as solving an equation. Gave us still a true answer. Okay, so that's good. We're good there. Let's go over here to subtraction. Let's kind of try to do the same thing here and say, what if we subtracted 2 this time from both sides? Well, 8 minus 2 is 6, and 6 minus 2 is 4. All right, let's see, is this still true? Is 6 greater than 4? Yeah, that's still greater than 4. So this is also true. All right, good. So we know right now when we do addition, when we add 2 to both sides or any number, we're good. If we subtract a number from both sides of an inequality, we're good. Okay, so far so good. Let's look at multiplication. Now I've got 8 is greater than 6 down here. What happens this time if I multiply by 2 on both sides? 8 times 2 is, 16. And 6 times 2 is 12. Is that true? 16 greater than 12? Yep, it's true. Good. So we're looking pretty good here. Now there's one thing here with multiplication. Let's look at one more thing that could happen. What if we multiplied by a -2 on both sides? What happens this time? Forgot the negative. This time, now I have -16 greater than -12. Is that true? No, it's not true. So here's our first situation here where, our rules that we had before for solving equations doesn't work. Well, what can I do to fix it? Well, I know by looking at these and seeing the numbers, I know that this is going to happen every time I multiply by a negative. So in this case, what I have to do here is I know that this is false. So I just switch the inequality sign around. So whenever I see that I multiplied by a negative, I say, well, -16 is less than -12. That will make this true, and then we're good. Okay, so addition, everything stays the same. Subtraction, everything stays the same. Multiplying by a positive number, everything stays the same. Multiplying by a negative number, we have to flip the sign around. We have to flip the inequality sign. And then the last one with division, last one with division, let's say I divide by 2. So what do I have? 4 is greater than 3. Is that still true? Yep. Good, we found another one that works out. We don't have to change. But there is one more thing to look at. If you hadn't guessed it already, divide by a -2. What if we divide by a negative? This time, what do we have? We end up with -4 is greater than -3. Is that true? Nope, that is not true. That is false. So here is another situation where we're going to have to flip that inequality sign around. And so what we end up with here is we have to write -4 is less than -3. That will make it true. So those are the two situations. Anytime we multiply by a negative or divide by a negative on both sides when we're solving our inequalities, we have to flip the sign around. Okay? And to emphasize this, I want you to take a look at this. So, as a reminder there, I added some special effects. When we multiply or divide by a negative number, and that's on both sides of the equation, then we flip the inequality sign around. Okay? We have to do that every time. Other than that, everything's exactly like solving equations. Okay? All right, let's take a look at a few examples here. Solving an inequality, first one here is pretty simple one, pretty straightforward. These are both one-step inequalities, okay? So all we have to do is one operation here, just like solving an equation. I'm trying to get y by itself, and 6 has been subtracted from y, so what do? I add 6 to get these to cancel. And if I add 6 to that side, I have to add it to this side. Do I have to flip the inequality sign around? Nope, I'm adding. That's okay. I do not have to do that. So what I end up with here is y is less than 9. Okay? Now let me point something out here. Actually, let me change one thing here. Let me just erase that for a second. There is something called set builder notation. I talked about it in Algebra 1, and you know, if you can get used to doing this, it's good. It's kind of a technicality in a way, but the way that we have what we have written right here for what we just solved, technically is y is less than 9. So it means there is some number y, whatever that is less than 9. But what we really mean by this is we want to say that all of the numbers less than 9 can be a solution. And so that's somebody somewhere came up with this set builder notation. Basically, you're going to put those squiggly brackets around this, so I'm going to try to do it without having that thing pop up. So squiggly brackets, and then there's going to be a line in front of this y, and then another y out front with the squiggly brackets. So the way that you would read this, you would say, well, the squiggly brackets mean it's a set of numbers. So you would read this by saying it's a set of numbers of y, such as or where y is less than 9. So you're technically saying, hey, this is all the numbers less than 9. Okay? So that's set builder notation. And then when we go to graph this, on our number line here, we mark off 9, you know, and then we can have a few other places here, 8, 7, and so forth. Well, 9 is obviously a key spot here. And in this case, do we have an equal sign under here? No. So do we put an open circle or a closed circle? An open circle. Okay, good. So we put an open circle on this because we have to tell where the boundary is. But if I put a closed circle, that means 9 would be part of the solution, and we don't want to say that. We want to say that only the boundary is at 9, but not including 9. And then if it's less than, what numbers are less than 9? 7, 8, 6, 5, all the numbers going this way. So we would draw an arrow going to the left. My graphs aren't really good on this thing. Negative 4x is greater than or equal to negative 24. What do I do there? Well, negative 4 is times x, so I'm going to divide by negative 4. So these cancel out. Did I divide by a negative? Yep, I did. Okay, look it. There's a negative 4 and negative 4. I divided by negative 4 on both sides. This negative right here in front of the 24, that doesn't make any difference as far as telling you to flip the sign or not. It's only the sign that you divided on both sides, okay, which was the one in front of the 4. So when we do that, then we have x is less than or equal to, we flip the sign, and negative 24 divided by negative 4 is a positive 6. And again, if we want to try to put that into set builder notation, it would look like this. So set of numbers of x where x is less than 6, and then when we go to graph it, here's 6, 5, 4. Do we fill in the circle on 6 or leave it open? Well, before, when it was not equal, we kept it open. This time it does equal, so we want to put a dot on that. Filled in dot, and this is going to be hard because it wants to keep popping stuff up here. I'm going to have a hard time drawing a dot. And then it goes, since it's less than, it goes to the left. Okay? Just a quick review on the graphing stuff there. When it says greater than, and again, the arrow is an open circle and goes to the right. Now this is only if you're writing the variable first. So for example here, if you write x is greater than 5, then this will be the case. If you wrote that backwards, the sign would be backwards. So these only apply when the variable is written first, which if it's not written first, you can flip it around to write it first before you go to graph it. So you know here, y is less than 3. It would have to be written in that order. Or in this case, z is greater than or equal to negative 3. Or r is less than or equal to 22. So that's what your graphs will look like on those. But again, the variable has to come first. All right, we got a few examples here with some multi-step inequalities, and then we'll be done. Just like an equation, we're going to follow the same steps here on this one. So what comes first here? Okay, we're going to do the addition and subtraction first. So if it's adding 5, we're going to subtract 5. So now, oh, do I switch the sign? No, that's right. Even though it's minus 5, that's not dividing or multiplying by negative. It's just subtracting, so that's okay. And so that would be greater than still. And 23 minus 5 would be 18. Then we would divide by negative 3, and at this point you should be going, oh, divide by negative 3. We got to change it. So y is less than negative 6 this time. If you want to do set builder notation, you can add that in. Again, normally we would graph it here. I'm not going to take the time to graph this, but it would be an open circle on -6, and your arrow would go to the left. Okay, what about this one? This one's a little bit different because we've got a fraction in there. And so in this situation, you do not want to do the adding 58 where you subtract 58 first, because this is not really a 58. This is 58 divided by 6. So that kind of throws things off a little bit. Now, I would not suggest making this 5c over 6 plus 58 over 6. That's going to be really confusing. Whenever you've got a big fraction like this, the whole side is a fraction, here's what I would do. I'd multiply this by the reciprocal of whatever's on the bottom. So times 6 over 1. Why would I do that? Because this 6 will now cancel that 6. And as long as I do the same thing on this side, I multiply by 6 over 1, then I keep it balanced. Did I multiply by a negative number on both sides? No, it was a +6. So this is okay. We're not going to change the sign here. So now I have -24c is less than or equal to 5c plus 58. I want to get this. I'll probably just go ahead and get this 5c over here. I think that'll be easier. So I'm going to do -5c. That gives me a -29c. Did I multiply or divide by a negative? No, I just subtracted, so everything stays the same. Last step is I'm going to divide by -29. Oops, there it is, divide by -29. That means, flip the sign around, c is greater than or equal to, and 58 divided by -29 would be a -2. And set builder notation would look like this. Again, I'm not going to bother graphing this one. I think you should be probably pretty good with that. But we put on our number line graph a filled-in circle on -2, and the arrow this time would go to the right on our number line graph. Last example here, and then we'll be done. When I look at this, I go, hey, you know what? Looks like I have to distribute this 3 first. So I'm going to distribute 3. So 3r plus 6 is less than r minus 4. Okay, what do you think you're going to do next? Oh, get the r's together. Good, okay. So, minus r, minus r. I would do that because then what I have over here now is 2r. And then since we've got the r's all together on the left side, I'm going to take this 6 here and move it over. So I'm going to do that by subtracting 6. So now I have a -4 minus 6, which is the same thing as a -4 plus a -6, so -10. And now what do I do? Divide by 2. Now, do I change the inequality sign around here? What do you think? I mean, look it. I got a -10 here. Shouldn't I switch it around? No, good. Okay. You do not flip it here, because what I divided by was a +2. Do not get fooled by seeing a negative here and thinking that you have to flip it. That negative does not make a difference. The only thing that makes a difference is when the thing that I divide both sides by, in this case it was 2, that's positive, so I do not switch this around. Okay, so what we end up with here is then r is less than -5. That one stayed the same. And set builder notation would look like this. Okay, well, let's look at solving single-step inequalities, one-step inequalities, and multi-step inequalities. Thanks for joining me, and hope you have a great day. We'll see you next time.